Welcome to the project demonstration of simple automatic control clap switch, and you're using SSR as a solid state relay. So in this one we are going to switching the loads based on the solid state, which has the inbuilt solid state one. So whenever we provide the trigger pulse to this input of this one, there will be a diode will get switched on, and this diode light fall on this secondary end. So the secondary end will start conducting the solid states, so that the power supply will be flow from the inputs to the output loads. So this will be controlled through the PIC 16F72 microcontroller based on the sound input from this sound sensor. So we have set the sound limit with help of this potentiometer. When we are rotating this potentiometer screw anti-clockwise, the sensitivity will be decreases, and when we rotate that in clockwise, then the sensitivity will be increases. So lower sound also will be detected when you are rotating this in clockwise, and counterclockwise is heavy sounds will be detected. So now we set for the normal sounds, and so that output from the sensor is given as input to the A0 pin of our PIC 16F72 microcontroller. So it will start reading input from that. Based on that trigger pulse from this one, so it will change the state of this relay. So means if it is off, then it will change the state to the on, and if it is on, change the state to the off. So this toggling nothing but. So that relay was connected at the pin number C7. So here we are providing 230 volts AC input to the whole circuitry. So that is parallelly given to the loads and to this regulated power supply board. So the regulated power supply board will take 230 volts AC inputs and provide us the 5 volts constant DC outputs. So it has a 4 stages: transformation, filtration, regulation. So like the transformation will step down the 230 volts AC to 12 volts of AC, and rectification will convert the 12 volts AC to 12 volts pulsating DC, and the filtration will remove the pulses, so we will get the pure DC voltage. But we need 5 volts as operating voltage for the relay and microcontroller, and sound sensor is a 5 volts. So for that purpose we need to regulate that 12 volts DC to 5 volts DC. So we will use a 7805 regulator. So that after these 4 stages we will get the constant 5 volts DC. So when we providing that here, so it start reading input from the input sensor and will be control the output module. So on this motherboard we can see the 3 major components. One is the main microcontroller, which will taking care of inputs and outputs, and a crystal oscillator, which will use it to provide the 20 megahertz of clock frequency to execute the instructions, and reset switch to restart the microcontroller. It won't erase the program, just it will reset the microcontroller. That's it. So let us see the demonstration. So you need to make the most sound to detect that particular sound by the mic sensor, and that is the input to our microcontroller. So we can make any hard sound. So it will get off. Right. So by rotating that counterclockwise, so we can decrease the sensitivity again, and clockwise we can increase the sensitivity. While we're talking also, this particular will get switched on. So when this on, so indication of the controller getting the signal from the digital output of this sensor. You can see that when I make a sound, this light will get switched on. So you can see that. So when it is on, then only the output will be given as input to the microcontroller. Like that.